Today's lesson is about triangle inequalities. We have three theorems to learn. The first one says that if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. If we consider triangle ABC, which has side A directly across from angle A, side B is across from angle B, and side C is across from angle C, we notice that this triangle has three different size angles and three different length sides. This first theorem tells us that if side A is larger than side C, then angle A must be larger than angle C. Our second theorem says if one angle of a triangle has a greater measure than the other angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. As you can see, these two theorems are directly related. So essentially, in any triangle, I can always conclude that the largest angle will be across from the longest side, and the shortest side will be across from the smallest angle. And then, of course, the one in between, B in this case, will be across from also the medium length side. Our third theorem is the triangle inequality theorem. This one says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. For this example, let's consider triangle DEF. In triangle DEF, what this theorem tells us is that I could take the measure of sides DF plus the measure of DE, and if I add them, they will be always greater than the measure of EF. So remember, when we name the distance of a line segment, we label it as the 2 points, the beginning and end point, with no symbol over top. So I can conclude that DF plus DE is greater than EF. I could also conclude that EF, this distance here, plus FD, this distance here, would have to be greater than the third side, DE. Similarly, I could also say that EF plus ED will be greater than the distance DF. This theorem holds true for all triangles, whether they are right triangles, acute, obtuse, any kind at all. Two sides will always have a sum greater than the length of the third side. If this was not true, such as in this example here, if I considered this to be the start of a triangle, and I had a long side that was 5 inches, if I had two other sides, one being 3 inches and one being 2 inches, the two sides would not be able to meet and create a triangle. If I collapsed these two segments to be flat against the 5-inch, I would simply end up with a line segment. Therefore, it always has to be greater. The two sides added together cannot be equal, and they certainly cannot be smaller.
Oops!